So here's the setup. I have just a standard ordinary bike, and it has a hub generator on it. It's actually a hub motor that I'm using in reverse. And what I do is, this is the connector that comes off of it. And so I just made a connector to work for it. And then 3 wires. So this is 3-phase power coming off this generator. Each wire has a phase. Now this doesn't have a ground, so it's going to confuse me a little bit, but I've got that 3-phase energy coming off there into a 3-phase rectifier, which now gives me a plus and a minus DC. Okay, I run that into a capacitor to level it out a little bit more so it's more stable, because this output at this point of the output of the rectifier is, I don't know if you want to call it wobbly, but it's not a pure perfect DC. So I then run that into a pretty big capacitor. You can see here it's 100,000 microfarads. Okay, so pretty powerful one. And that thing's charged up. You put a screwdriver across that, it makes a big scary spark. Then I'm running it into just a power meter. This is an E-Flight power meter. It'll just show us voltage and current and power. And then I run that into the brains of it all, called the SunSaver MPPT tracking device. And you'll see this here. Now here's my fingers in relation to it. Okay, so it's not huge, but this thing is awesome. And then that output is going to run to my battery. So that'll be the charging battery. Now, what this little phone cable is, it's not a phone cable, it's some kind of special cable, I forget what kind it is. But this just runs up to this meter that I have taped to the bike. And you can see this, so it's going to give us the outputs. And this is called the RM-1, and it's specifically made for the SunSaver MPPT and I think a few other things it works for. So what's going to happen here is, as I pedal this thing, power will come out of the generator. It'll turn into more of a clean DC because of the capacitor, and it's about 30 volts. We'll monitor the voltage here. When there's no load, it's around 30 volts. When it's loaded, it's less than that. And then like I say, the SunSaver MPPT device is what is really, really neat and how it works. And then I can use that meter up on top to monitor the power levels going into the battery. Now what I could do here is I could actually put one of the E-Flight power meters right in line, say right here, and then I could monitor both things more effectively, because this monitor up here on the bike is kind of slow. It updates every, I don't know, it seems like 10 seconds or so. So it's a little less exciting to watch, but it does give you the correct information. So I'm going to compare what's going in, what's coming out of the generator, and what's going into the battery in terms of wattage. And that's really what I want to see. I want the most efficient power transfer I can have. So this is the setup, and I'll kind of show you how it is. I'm still waiting for the battery to discharge enough so I can actually plug it in there, because you can't use this on a full battery. It's kind of silly. Now the other thing too about the SunSaver MPPT is it has this output on it right there, and so we can actually use this to power things at the same time as we're charging, I believe. So we will test that down the road too. So here's the simple setup that I'm going to use just to discharge a battery. So I have a fully charged battery right there. You'll notice that this is an AGM battery. Just got 9 amp hours in it. And I got this over at Batteries Plus. Worker is their brand name. So anyway, it's a 12-volt battery, AGM. I have a very simple setup here. I'm just monitoring the voltage on the battery at the same time as I'm going to be charging it. And right now there's no load on it. And I just have this coming straight over to a nice DC to AC converter. This is an Ames converter here. Nothing special about it. Just I think it's 180 watt power inverter. No big deal. It's just a nice sine wave inverter. So very simple. And I'm going over here to a lamp, and as you can see, it is a 40 watt light bulb. Why 40 watts? No reason. Could have used 100 watt too. it would have discharged faster. So I'm just going to turn this whole apparatus on here. It's just an on switch here. And so the light slowly comes on, and there I have it. So this is going to drain the battery, and I'll take this down maybe to 11 volts or something like this. And this will take a while here. I've drained these batteries down to 10.7 volts, and it took like 45 minutes to do. So I'm not going to sit around and make you wait and watch that. I just have to have a drained battery to then show you how to charge it back up again. So that's the setup. Real simple, couldn't be any easier. Okay, so I let the battery get a little too low. Went down to 10.4 volts, which probably isn't the best for it. But anyway, the light turned off because the power went too low. Battery voltage went back up to 11.68 with no load on it. Okay, so then now that battery I'm going to consider dead. Hopefully I didn't damage it. It's a little too low a voltage to take it to, in my opinion, but I'm not exactly sure what the safe voltage would be quite yet. So anyway, what I'll do is I'll shut this down, and then we'll hook the battery up to the charger and see what's going on. Okay, so I put the dead battery and hooked it up here, and you can tell that this is saying it's basically half charged. It's not fully discharged, so whatever it uses as a measurement for that, I don't know. And I just spun the wheels just a little bit here, and you'll see here that the capacitor has a little bit of power in it, especially when I start cranking here. I'm just doing this by hand. Oh, and already it got harder because the sun saver thing kicked in. So there we're at, that's only 14 volts, okay? So it gets up to, I think, 14.09. Now what's interesting about this is I'm going to be able to pedal, and the harder I want to pedal, in other words, the more effort I want to get into it, the more this device is going to pump into the battery. And this is the amazing thing, because you'll see here in the gearing that I've got the front gear at the largest and the back gear at the smallest. So that gives me the most speed, the revolutions. The brake's not hooked up, and this is very straightforward. Okay, and you'll see here this is just, it's pretty easy to install too. So what I'm going to do is I'm going to hop on the bike, and you see the voltage levels going down and down, because this thing, first of all, takes a little bit of power, and once this voltage gets too low, it starts drawing it from the battery. So either one will kind of power it. So I'm going to hop on the bike, and I'm going to see here that this is saying, this is basically almost the exact same voltage is down there. That says 7.92 and dropping. This too will continue to drop as it updates. So I'm going to start pedaling. Very easy to pedal, and boom, all of a sudden it gets harder. Now the coolest thing about this is the automatic gearing in this. Let's see, where is the... Oh, there it is. Okay, so it's going to be kind of weird trying to do this while I'm riding. So 13.8, I've got this set on voltage, but I'm definitely charging the battery. How much am I charging the battery? Let's see. How do I do this again? Got to hit. Oops. Got real easy all of a sudden, and then got real hard because the voltage dropped for a second. Okay, so the first number was the voltage of the bike, so the input. And this would be, you can remember, this is set up for a solar panel usually. I'm already kind of tired here. I'm cranking some pretty good power. Okay, so that's temperature. Again, that's the output of the generator. That's the battery voltage. Oops. And then from here, I can scroll over. Okay, so I've put in 10 amp hours so far. I'm putting in 8 amps into the battery. That's a lot. Here's the minimum voltage that, before the charging, here's the maximum voltage. Here's the volt amps. So I'm right now putting in 120 watts of juice. I'm going to slow down. So all I do is just let go and don't pump so hard. And you'll see this number come down. There it goes. And that's a lot easier to tolerate. 42 watts, a lot easier. Now you're not hearing any clunking of gears. The absolute neatest thing about this is that device, what it'll do, as it draws more current, it makes the generator resist you more. So I'm going to actually take this down to even a smaller level. I started pedaling a little harder and I went up to 65. Now, this, I shouldn't have done the 120 watts. I'm going even slower. And understand, this thing doesn't update very quick. It's like every 10, 12 seconds, something like that. So now this is very easily pedaling. I could do this with my hands. I go even lighter. And of course the pedaling gets easier automatically. See, and this is like nothing. This is just as much energy I'm putting in here as it would be to move my legs up and down with no resistance. Okay? Now down there, still says 13.3 volts. And there, it doesn't say anything. It says I have a fully charged battery, but I don't. That's not the most accurate thing. So now I started pedaling a little harder. Went up to 55 watts. What I'm going to do now is I'm going to set that sensor down there for wattage, and hopefully it stays on that setting. But just to show you here, I'll start cranking harder. And boom, automatically got harder. Oh, this is hard for me to pedal. Okay, automatically 120 watts, 116. See, I can go even more here. In a better position. Oops. Let's see how fast I can get this. It's not liking that. It's almost too much power. Come on. This is a heck of a lot more than 73 watts I'm putting in there. Okay. 170 sounds more like it. Okay, and I can't keep that up. Okay, so I peaked out at 170. Now, the trick is, put this in, it's in volt, amps, watts. So let's get on here before that thing shuts down. Good, I got it. Huh. Now it's not giving me a wattage number. Why? Anyway, I'm putting power into the batteries. There's no doubt. If I had that set right. This is saying 72 watts. And that feels about right. Get some watts. Oh, I have it backwards. Yeah, I have it backwards here. So let me. So this is the power. This should be the power source, and this should be the load. So I've got this backwards. Let me flip it around here. I'll actually pause this here for a second. Do it. Okay. So it was reversed. Now it's working. So what I'm gonna do here is this gives us some more instantaneous power reading. Okay, so with the difficulty level, it's right around 90-ish, and then now remember this is very slow to update. Pedaling is definitely harder than 70. So let's see when it updates here. Yeah, I guess it is around 70. I'm just tired. So, So anywhere, somewhere 10 to 15 watts. This device is using this. It loses some efficiency. It's not a perfectly efficient thing. But that is pretty darn close. Now I'm at 108 watts. Right? Well, that must have been for a second. Oh, so it got easier. This is where the capacitor could come in very handy. Having a better capacitor in there. Okay, so 90. This down there is instantaneous. That's the thing. So it's hard to say without this power meter jumping around here. But for sure, it charges the batteries very nicely and very quickly. They say there's about a 10% loss. That's somewhere around, that's kind of on the high end of this. Now occasionally, when I'm doing that, when I was charging this the first time, I wasn't trying to hold the camera and I was more consistent in the pedaling. And I didn't have this thing stop every once in a while. So what I mean by that is when I was pedaling, it occasionally get real light, real easy. And that's because the voltage on here got a little too ripply. So having a couple of those to feed in might be even a little bit better, a little higher one, higher than this. But when I was doing it on my own, it was a piece of cake. Now this, will get a little warm sometimes, so that's obviously some of the power loss there. But overall, extremely efficient. I don't know how you can make it any more efficient. The thing that's annoying is the delay time of this meter. I like the instantaneous ones a little bit better, but then again, they don't average as well. So maybe this one up here is averaging better. Anyway, so I'm going to put all the specs and schematics. Not that the schematic is real hard for this, but I'll put them all on the website so you can see how it's all put together. And I'll show you the links too as to where I got all this stuff. Very, very easy to put together and have your own way to charge batteries. Because unless you're an Ironman athlete, it's hard to make that power. There's no way you can power some 300 watt item, right? But you can do a lot lower power and then store that in batteries, which can deliver it in a quick moment. So anyway, I'll turn this off here and catch my breath. Now let's start talking about power, because when you start talking about generation, and power usage, you got to understand the basic concepts. So the one that most people are familiar with is the watt. You have 100 watt light bulbs in your house, you have 40 watt light bulbs. Everyone understands that in terms of wattage for light bulbs. And unless you're in engineering or like this concept of power, you really otherwise don't really see wattage used a whole lot in other places. It's usually the wattage of the light bulb. And that's how much energy it takes to run it at its designed and rated power. Now you'll see that wattage here, according to Wikipedia, is defined as joules per second. Now joules is a form of energy. That's all it is it's actually energy. It's the value that's used for energy. S stands for seconds, so it's joules per second. So if we come over and look at joule, joule is basically, it's a unit of energy, and it's this coulombs volt concept. You do not need to know this at all. At all, you don't need to know this. The J watt second is actually kind of a nice formula, but the J is just a unit of energy. So how this comes into play, there's lots of different ways to document how this works. Let me just close that down here. If you look at a 100 watt light bulb, that's 100 joules per second. So it takes this much energy every second to keep that light bulb lit. 500 watt device or a light bulb, refrigerator, whatever it is, takes 500 joules every second to keep that running. 1,000 watt light bulb or 1,000 watt drill or whatever is 1,000 joules per second. Okay, so it's very straightforward to think about that. So let's just say that we can only pedal at 100 watts. So we're talking about charging our battery here at the 100 watt level, and we're pumping in 100 watts into this thing. And if it was at 14 volts, what would that be? Times 8-ish, 8 amps. So the definition of power also in terms of watts can be volts times amps. So if you're putting in a voltage in a certain amperage, but that doesn't really matter in our case because the charger is going to put in whichever voltage it can and get the highest current it can based on the power that we're giving it. So you don't really have to think in terms of voltage and amps. You can, and those meters can all show that stuff. Even on the display that was on the bike, that can show the amperage that you're putting into the bike. But really the wattage is what you're more concerned about. You're concerned about how much power you're getting into it. So if we can only pedal at 100 watts, and let's just say, it's 100 joules per second, and let's just say we do that for a minute. How much power are we actually putting into the battery? So if you look at the equation, it's 100 joules per second. Okay, that's watts right there, that number. So you have to start thinking in watts in terms of joules per second. And we do that for 60 seconds. This is how long we're pedaling. That equals 6,000 joules of energy that we have now stored in the battery. Now let's say we want to power a 500 watt device. Okay? Let's just say that we want to power it for 60 seconds. If we want to power a 500 watt device for 60 seconds, well, 6,000 joules of energy isn't going to cut it. We actually need 30,000 joules of energy to run a 500 watt device for 60 seconds. So we're way shy of that. So what you have to do is you have to pedal, instead of for 60 seconds, you have to pedal for 5 minutes. 5 minutes, multiplying this by 5, will get you your 30 joules of energy. Does that make sense? So when you're thinking about powering higher type devices, that you just can't simply pedal and power without the use of a battery. You have to think of storing that energy in a battery to get the power that you actually need, because it's a power level. It's like you cannot pedal to get this. There's no way. I don't care if you're a triathlete. You're not going to be able to pedal 500 watts, even for a few seconds. But you can do this for a lot longer period of time. And that's where the batteries come in. But how long could we power a 500 watt device with that amount of energy we stored right here, with that 6,000 joules? Well, you take the 6,000 joules that you've stored and you divide it by the wattage. See, it's the wattage. So if you look at this here, the joules cancel each other out. The seconds gets flipped up on top because this is divide. So it's actually 12 seconds of runtime. So if you only pedaled for that 60 seconds, you could run a 500 watt device for 12 seconds. And then you'll notice there, if we multiply that by 5, that would be 60 seconds. Right? So if we did this whole thing for 5 minutes instead of 1 minute, we would have we'd be able to power the 500 watt device for the total of 60 seconds. And that is just counting energy stored in a battery. Right? You should never let your batteries where you're just powering them just enough to get what you need done. That'd be silly. You would usually keep these things fully charged, so you could probably run this for quite a bit longer, depending on your inverter, depending on the size of your batteries, stuff of that nature. The battery I'm using, it's pretty small. It probably could kick out this. I know it runs a 100 watt light bulb with no problem. So I've never really seen how much power you can draw out of them real quick. But I just have to have higher rated batteries. I wouldn't want to ever stress the batteries too much. So that's how you figure out this wattage stuff. So and you can go look and you can read about the joule and you can read about wattage. But it's very straightforward if you just understand those basic concepts of this. So usually what you want to do is you're going to want to charge your batteries fully and then use them a little bit and then charge them. And the neat thing about the batteries of this charger is you can actually have power being drawn right off directly from them, like I had that light bulb hooked up, and be charging them all at the same time. Because the charger isn't really going to care. All it's trying to do is put as much power into the system as it can, and based on your pedaling. So it's always going to try to find that nice max where there's the best power transfer. That's what that MPPT stuff is. So I'm going to pause here for a second and bring up that controller. Okay, so here is the Morningstar SS MPPT controller. And I got to admit, this is pretty darn cool how this works, because this thing called MPPT, it's was it multi-point? No, what's the name of this? Maximum Power Point Tracking. And I don't want to get into the details of why this works, but needless to say, it is the most absolutely, positively coolest thing you're going to have for this type of device. Because here's one of the problems you run into with this is, and this happened to me when I was running a instead of using this, I was running a DC to DC converter. So after the capacitor, I'd run that into a device which would give me a clean 12 volts out. Now that clean 12 volts out was limited by how much power I could produce in the wheels, or by turning the crank shaft, right? And so I could only get, 120, 130 watts consistently. So I could actually power a 100-watt light bulb just by pedaling. But the moment I stopped pedaling, the light bulb went out. And so where was I going with that? That's like the most efficient way you can do things, where you're doing that in a sense. And so what happened is, the more load, when I had that scenario with the DC to DC converter, the more load I had on there, I had to almost change the gearing ratio to make things almost a little easier. It didn't really matter in that sense, but I was playing with the gears. And I didn't want to have to play with the gears on the bike. And I wasn't taking them on and off, but the pedaling, I'd shift from 12, how many gears I think I have? 12 or 15? 15 down to 14, down to 13, so it'd be a little easier to pedal. Stuff like that. Now with this thing, the reason why this is so dang neat is this acts like an automatic shifting device. And what I mean by that is, when I was on the bike and I wanted to put more power into it, all I did is I started pedaling a little harder and a little faster, and it got harder to pedal. So like if you've ever seen this, if you've ever tried to pedal against a generator, the generator, if you short it out, it's impossible to pedal against that thing because it's a dead short. There's so much current flowing through that you can barely pedal the bike at all, no matter what gear it's in. But then if you open up the wires, you can pedal that thing, and it's not even like it's like the generator's not even there. Well, this acts as like an in-between, and it regulates between a full short to an open circuit. And I'm saying that a little, it's not quite that broad, but it regulates in between. So when I started getting tired, I just started pedaling a little slower. It realized that the available power from the solar panel, which in this case was my pedaling bike, it was less. So it shifted things down, so it not only made it easier for me to pedal, but it also put less power to the batteries, but it still did it in a very efficient way. So it's still good power transfer. So even though I was pedaling less, it still worked very efficiently. And you can read all about this MPPT stuff. I have all kinds of companies out here. Solar Home was the cheapest price I found. So look at this, $195. Here's the same thing, and they're charging $225. And then you can get that remote digital thing. Here's the RM1. Okay, so that's what I got with it. The cord came with it too to hook it up to this. And this is the other thing too, is the controller I was using can only handle up to 200 watts for a 12-volt battery system, which is what I was using, or 400 watts for a 24-volt system. Now I haven't tried this with 24 volts, and I could easily do that. And the reason I haven't done it is because, first of all, I can't even go over 200 watts. There's no way I can do that. But my voltages too, I gotta always have my voltage in the input. So in other words, after the generator, it's always got to be higher than the batteries that I'm charging. So, I'm close to that 28, 9 volts, something like that. So I haven't tried it with that, but I could do it, and it probably would work. Because as long as my generator power is more than a few volts higher than the batteries, the voltage has to get a little higher than what the battery voltage is to charge them, because you got to put current into them. So if you're trying to charge a 12-volt battery with another 12-volt battery that's the same voltage, you're not going to get any current flow. But if you're trying to charge a 12-volt battery with another battery that's, say, 12.5 volts, then current will flow from the 12.5-volt battery into the 12-volt battery, and eventually they'd equalize. Well, same thing with the generator. Your generator has to be a little higher voltage than the batteries you're trying to charge. So this is an ideal controller for many small systems. And that's exactly what I'm doing, is I'm doing a small system. Now this can handle voltages up to 75 volts. Now remember, these are designed for solar controlling. And when I called the engineer for Morningstar, he says, that's interesting. I've never heard of anybody using our controllers in this way. And I never thought it would work. I'd read a blog at one point, or somebody posted something, and they said this wouldn't work if you were just trying to power some consistent thing like a 12 volts, like a power supply would put out. And that's because this doesn't change fast enough to do that. But when you're doing batteries, this is what you want. And then when you're charging batteries, and then right from the batteries, or even from this output right here between these two terminals, you can hook up to as much as 400 watt device, pulling the voltage off of that. And I think it's whatever the battery voltage is. So if this would be 24 volts if you're doing a 24-volt battery system, or this would be 12 volts if you're doing a 12-volt system. I need to look into that, but I don't really care right now. because I just tap right off the batteries themselves if I want. But the nice thing about this is that, you know, I think it switches if you're given it enough input power. Then let's say you're given this 300 watts of the input from the solar panel, and you're only drawing 100 here. Well, it's going to take that 100 watts probably from the solar panels and then use the other 200 to charge the battery through these two terminals. Oh yeah, I'm sorry. These two go to the battery. It depends on if you're using that or not. And then these two, I'm sorry. This is the input from the generator. This goes to the charging battery, and this is an output. And you can see that right from the specs. This could be plugged right into an inverter, for example. And this whether this is connected or not tells this device what kind of battery you're using, along with these plugins. These little flip switches are called dip switches. Okay, so there's a lot of complexity to this. There's other controllers that can handle a lot higher power. So here's a higher priced one. We'll click on it real quick. This is a much more intense one. But look at that. Highest peak efficiency is at 99%. Where else do you find that? But this can handle a lot higher voltages. So 150 volts input as an open circuit. And it can handle 45 amps. So this could handle much higher things, more than you'd ever want to deal with on a bike. But this is, again, for solar stuff. And I'm using that other one for a much simpler purpose. Now what this 75 volts open thing is open panel is basically when this isn't drawing any current, you cannot have the input voltage exceed 75 volts. So if you do have a generator that's, say, producing 72 or 75 volts, be extremely careful with that, because you'd probably blow this up. You'd want to go with the one that can handle a higher input voltage. My generator is only kicking out max, I think, 40 volts. So it's very safe to use that even if there's nothing hooked up to this, etc., etc. So that is that. This is very simple to hook up. And I'm going to pause here again and show you the next little piece of the puzzle. By the way, before we leave this, there are a lot of other different types of controllers. So you'll see here that there's a lot of different companies that make different controllers. I don't know if there's any better or any worse. Morningstar is just what I keep running into as being the better one, so I chose it. And they had this real nice one here that's called the Sunsaver. By the way, too, the reason why you want the MPPT is because of this automatic shifting effect. If you get like this one, this is not an MPPT controller, so it's important what not to get here as well. This will not have the efficiency. So what this works in a different way, and I'm not going to get into it. You can read all about MPPT, and here's a link right here. What is maximum power point tracking? What is this stuff? And this, so here's something from Wind and Sun. Okay, it's a solar, this MPPT solar charge controller. You really want something with MPPT, otherwise you're going to be wasting a lot of your power for nothing, and it'll turn into heat in the actual controller itself. So read this, you'll get an idea of why this works and how it's so good. But I don't think, in fact, I know you will not get that effect of the automatic shifting unless you have the MPPT. So don't go cheap on this and just get something because it's a little cheaper, because you'll notice that they are cheaper. This one's $75 versus the other one, which is $200, and yeah, $200. But you want this. You've got to have that MPPT. Okay, pausing again. Okay, so the next thing to discuss, which is very important, is actually the rectifier. And really, I should have shown you the generator first. But the generator has lots of options. And I'll find that invoice here, and we'll find that company. But anyway, so a rectifier is a device that takes three-phase power and turns it into DC. So if we look here, which one do I want here? So thebackshed.com. So this website here is available. Here's the link right up here, so you can type that in. But this goes into talking about the different types of rectification, and usually you're dealing with a single phase signal. So this is like out of your wall, and you want to try to convert that into DC. Well, there's half wave rectification, full wave rectification, and then there's three-phase rectification. Now you can make a three-phase rectifier with 6 diodes, But why do that? Just buy one. It's $6.60 plus some shipping, and it has 3 inputs and 2 outputs. There's a positive and there's a negative, and these are marked right on the device, I believe. Otherwise, they're in the data sheet. We can look here. Here's some big hefty ones. You do not need a big one. The one I have here is just fine. And where was it? Did I just cover that up? Yeah, there it is. Okay, so this you can get from DigiKey. You just set up an account with them. Very easy to order. You can order some other parts from them too. Again, you can see $6.60. Just buy a couple of them because the shipping is more than the actual parts. And there they are. And you saw they're 1.5" by 1.5" and they're kind of thin. I can't see here which ones are the outputs, but 3 of these are the 3-phase, and then the other 2 are the positive and minus, or vice versa. But this is the part number you're looking for right there. So FUS 45-0045B-ND. Now, if you need higher power levels, you can get this, but this can handle 45 amps. You ain't going to get that high on this type of device. The max I can produce is maybe 10. A Triathlete, maybe 20. Let's see, 14 volts. It could probably go a little higher, but they're not going to be able to do it for super long. And if you have to heat sink this, there is a metal plate on the back, and I don't know if there's a way to secure this. I don't know if you hold it down or what, but I've felt I've been able to touch it afterwards, and if you know anything about electronics, that's not bad. It's a little hot to the touch, but no big deal. So anyway, that's where you get that part, and I'll show you in the schematic how to hook that up. It's actually very straightforward. So let me pause that here, and we'll go back. We'll find something else here. Okay, so now let's go on to the actual generator itself. So we've covered this little device, which is the 3-phase rectifier. The capacitor, I can show you where to get that. We talked over this whole controller and then this device here. This I just got at a hobby shop, actually. You don't even need that. But I'll show you where to get that too, and I'll show you where to get this. But first, let's talk about the generator. So you get this, at least I got mine, from these guys over at electricrider.com. Okay, and you see I've done a lot of research on all this human pedal power stuff here. There's lots of good stuff on the internet about this. But to make some simple system was always kind of difficult. I don't know, I've been working on this a few years, and I'm an electrical engineer. So it's been a hassle to learn how to do all this, and the biggest problem I ran into is how to get the voltages correct. How do you take something that's kicking out 30 volts and get it to a useful voltage? Because nothing runs on 30 volts. And then to be able to charge batteries and all that stuff at the peak efficiency and the least cost without having to build anything. The last thing I wanted to do was build a circuit. And believe me, I went down that route, and it just was once I found that MPPT controller, it was great. But anyway, so here's a full setup here. Now these are bike conversion kits. And remember, I'm buying a motor that I'm using in reverse. So a motor is nothing more than a generator used in reverse. They're the same thing. All you need is coils with magnets moving around them. If you energize the coils, then it becomes a motor. If you use the magnets to energize the coils, let me say that. If you energize the coils with batteries, then it's a motor. If you use the magnets inside the generator to energize the coils, then it's a generator. Doesn't matter. But all this other stuff here you do not need. All you need is this thing right here, as you can see on the bike. Where is it? Right here. So that is what I got. You can see that is the exact same thing on their website. Okay? And it's got the cable coming off of it that they either have it tucked behind there or they're just not showing it. But you got to call them up and find out what you want to get. And you don't need all the other stuff. So you're just gonna have to call them and find it, because you can just get the generator itself. So let's look at the motors. Phoenix is what I have. So here's the actual motors themselves. By the way, you do not need the whole outer part. You don't need the spokes with the actual wheel part of it. All you need is the centerpiece. The reason I got that is because I also wanted to have this as actual bike. If I ever wanted to convert it into an electric bike, I could do that just by disconnecting my whole setup and using it as an electric bike. So I got it with the spokes and with the outer thing, whatever you call that. There's a name for it. But all you technically need is the generator. And there's different sizes for these. Which one did I get specifically here? Let's see. It's Phoenix Motors. So there's these different, so I was asking questions about which different ones there were. And I'll pause this here and I'll try to find the exact one that I got. Okay, it looks like I got the 400 series, and they're talking about the increase in price here. And there's no circuitry inside the motor. Now, by the way, that's another thing. For when you're learning about this stuff, you're going to realize that to make an electric bike, there's 3 coils inside these generator or motors, and you have to energize the coils at specific times to make it work as a motor. You don't want to energize all 3 coils at the same time. They're timed in different intervals. Anyway, inside the motors can actually they can actually come with little sensors, and they're Hall effect transistors, I believe, and they can actually tell a microcontroller that's powering these things how to energize the coils in the most efficient manner for battery storage and best power transfer to make you go forward. Now, you don't need that. You don't need that those electronics at all. So you can get that without it, and they come either with or without it. And so let's see, I'm not exactly sure which one I got here. I think mine was a 24-inch wheel. You just have to find out what your bike is. I think 24 is the most common. And then I just got one of these motors here. They all seem to be, so these are front wheel, so I didn't want that. Here's a rear wheel, Brute 2, Crystalite. What's the difference here? Oh, so here's the front wheel. Okay, so here's front, and front. We don't want any of those. So it's either this one or this one. They're the exact same price. This is an HT35 and this is an HS35. This is the Cruiser and this is the Brute. I believe I got the Brute. Let me double check. Okay, it was the Brute version that I got. The difference between these two is one's geared for more torque and the other one's not. So it probably wouldn't matter which one you got. They're the same price, but this is the one I got. And the price has gone up $20 since I bought mine like over a year ago. But it's a great bike. A great motor, I should say. And like I say, I got it with all this extra stuff on it. So as you can see in the picture there, it's there. I could put an actual tire on this and I could pedal this thing around. Now there is some inherent resistance in this just from the magnets running over the motors. It's not something you're going to want to go out and pedal on for fun because you want to put your regular wheel on this, but it wasn't any problem. What I would suggest doing too is ordering the opposite clip for this. So this part comes with a motor. If I zoom in here, now what I did here is this is 3 Anderson connectors, and I'll show you those too because those are really nice to use. I use them here, 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 here. I use them everywhere, and they're just nice for hooking things up. And so I'd order the opposite clip for this because it's not quite as convenient as this whole nicely mounted thing they have here. So a couple things. The other thing is the gears on the other side of this. And I showed that to you just briefly, but it's just like any other wheel. You got the 5 gears over there. You just got to order it correct for your bike. The reason why I suggest getting it is because I had problems. I first got the motor without that, thinking I could just go down to the local bike shop and get the gear device for it and just screw it in. I even have all the tools. I got a generic tool set for bikes, so I could take the stuff on and off and not ever have problems with the tools. And so I took it down there, and we couldn't find one that was right for it. And I called these guys back, and they're like, "Well, that shouldn't have been too difficult." But anyway, I ordered one from them, and it worked perfect. So when you get the motor. If you don't want this stuff, that's fine, but at least get the sprocket or whatever the gear stuff over on the other side is called, I forget. And then get the opposite connector for this. And those are the 2 big things you want to get. The other thing that could always be done with this is actually make a flywheel out of it. So you put like a tire on this and then put BBs through the whole thing. It might make it a little more consistent as well. That was the other reason I wanted this, in case I wanted to go that option. Because remember, all this stuff was just a big gamble of whether it would work or not. And I had this and this before I ever found out about this. So I was using, again, after this, a DC to DC converter just to give me 12 volts so I could run something, that was under 100 watts, like a TV and a DVD player. So like that's easily you could run for under 100 watts. You could sit down and watch a movie by just pedaling. So that is the bike stuff. So call these guys up, and so there they are. You can order the stuff. If you want to become a distributor for these things, I think you can even do that. I don't know. I don't know all the details about this stuff, but like I say, get one of these devices, get several of them, get as many of them as you want. But you do not need all the other stuff. You do not need the conversion kits. You do not need the electric bikes, unless you want to make that. You do not need anything other than the generator itself. Okay, so I think enough on that. Let me pause and see what else we want to go on to. Oh, by the way, you could have any type of generator you want, just as long as it has voltages above 12 volts. Probably above actually 15, because you got to be able to charge. So if you have anything that is making a voltage, that's all you need. And you can make these things run on wind power if you wanted to. It's just they're more set up to be spun like this. But you could put props on this thing and have this thing be a wind turbine. It just has to be spinning fast enough to get to the voltages you want. And like I say, when my bike is geared, the highest it can go right now. So I'm on the biggest sprocket there and the smallest here. So when I'm pedaling, and I'm not even pedaling at a fast pace, the tire's going plenty fast to create the voltages and make everything work. I could even make it where there's a single gear there and a single one in the back, but this is kind of like a 15 speed, and I don't know, how I do that. But I like the fact that this thing does the shifting so that my gears and all this stuff don't wear out. I like that a lot because I was worried about all this stuff that could break, and I don't need any of it. I don't ever need to change the gearing here. I don't ever need to shift. I don't ever need to do anything. It's just the simplest is the best. And I like it being electronically controlled versus mechanically, because mechanical stuff breaks down much more frequently than electronical, at least in my opinion. Okay, pausing again. But anyway, if you find other generators, go for it. They usually don't tell the output voltages from them, but you could probably tell by the type of batteries that you use to power them. So if it was being used as a bicycle, an electric bike, you could probably tell by the voltages that this thing needs as to how much voltage this will put out if you use it in reverse. Okay. And then just for getting the bikes up on something, you have to have a trainer. Okay, so this is the accessory, this is for the front tire, and then this is what's in the back. Now I did not install this piece because I don't want to have any more resistance like that would create. So I just have the back piece here. As you can see, I left that whole thing off. That would normally be pressing against the wheel for you to have some resistance, and then there's for the stationary for the front. Real simple there. You can find that anywhere. By the way, I ran across this website. This is the Crystal Light website, and this is the makers of these motors that I'm talking about. So Crystal Light, at least where I last saw from this electric rider, Crystal Light was making these Phoenix motors for them. See, there you go, Crystal Light right there. So you can go to the Crystal Light homepage and contact them. You can become a dealer. You can be where to buy them. So if you want to make a business out of making these things for people, I mean, you can always do that. I'm putting all this stuff up here free because I think everyone should be able to make these things, and they're fun as heck. And why pay another $1,000 or $2,000 more for someone else to make it for you? Just make them yourself. But if you have no interest in it and just want somebody else to make it for you, you could obviously buy it. Okay, so that's crystallight.com. Okay, so here's the capacitor that I bought. And you see it's 100,000 microfarad. Okay, so that's a pretty big capacitor. It's 35 volts. Okay, so it's protected. I'm not going to be capping out the voltage of this thing. It's $32, and I got two of them in case I blew one out. Okay, turned out one of them didn't work so hot. And so now here's the thing I learned, understand about this too. The 35 volt is kind of important. Now, if any of you know anything about supercapacitors are pretty nice, but it's hard to find them in these types of voltages. So supercapacitors are also relatively expensive. So this is, what is this? This is actually 0.1 farads, right? Yeah, 0.1 farad capacitor. And that's a lot of capacitance, at least prior to superconductors coming around. But the problem with superconductors is they're usually 2.5 volts. And then you have to string a whole bunch of them together to get to this type of voltage. and then you have to make sure they're balanced so that you don't go over the 2.5 voltage for each one. So if you start looking for supercapacitors, you're going to realize that it's just a big, icky mess that you don't need to get into. So, supercapacitors. Let's see here. So here's like a small one. Or these are pretty potent, but this is probably a 2.5 volt. And the Maxwell just seems to be the most awesome supercapacitor place that I have seen. But look at the voltages here. So here's 350 farad. Okay, I'm saying my capacitor is only 0.1 farad. So this is super huge comparatively. But look at the voltage. So and then to string if you go over 2.7 volts on this, you fry it. So you got to look at these supercapacitors. And let's see if we try to find a 35 volts supercapacitor. Well, this isn't gonna give me anything. Okay, so you see this is still 5.5 volt, 0.1 farad. Okay, so it's just good luck finding one. If you can find one that's a lot higher voltage, but I guarantee you they're not worth the hassle because of all the electronics you have to keep these together. And you can, let me just pause this real quick and just show you. Okay, so this might be an option for you if you've ever looked into supercapacitors. If you wanted to get something, let's just so these are what are called audio capacitors, and these are you put in your car, and they help provide power to stereo systems that need a lot of juice, especially for the low end bass type work. And you can see here that the working voltage is 21 volts, and surge voltage is 24. So with my system, I'd blow this out. But if I put two of them together in series, I'd have a heck of a good capacitor. And this would be pretty darn nice. That's 6 million microfarads. So that's 6 farads, or 6,000 farads. Micro, just get rid of this, the micro, so you got 6,000 farad capacitor, which is great. And that's actually that's a pretty good price for all this. So you could use two of those in series, but it all depends on the voltages you're working at. If your generator never goes over like 16 volts, then one of these would be just fine for you. But for mine that goes up to 30, 35 volts, well, this I'd be blowing this thing. So that is an option if you're looking at supercapacitors. But typically, you're not going to want to deal with them. You just deal with a regular capacitor. But like I said, mine could afford to be a little bit bigger. I could use two of mine in parallel. But I like the larger voltage of, where was that? I already got rid of it. I like the larger voltage of that capacitor that I showed. Actually, no, I showed it over here in this invoice. So here's the capacitor right here. Here's the part number from, again, Digitech, or DigiKey, I'm sorry. So if I just go over to DigiKey again, and I type in, so here was the three-phase generator. Just type this in, it should show me the capacitor. So there it is. Comes with these screws, $21. Wow, cheaper than what I got it for. Yeah, it actually went down in price. So I bought mine for $32. There you go. So they're cheaper, and you can take a look. But again, this is a pretty hefty, old-style capacitor. Just a regular electrolytic. It's again 0.1 farad, but it's 35 volt. So there's the trade-off. When you go over the higher voltages, you don't get as much capacitance. But again, this isn't even an ultra capacitor or a super capacitor. The names are used interchangeably. So that's the type of capacitor I used, and I'll try to put this link again in the YouTube video and show you that. So I'll close that down. Got a lot going. Okay, so here's the power meter that I used, and you could tell that when I hooked it up backwards, it didn't blow it. It just didn't show the wattage correctly, right? But it did show the voltage correctly. But anyway, you got to get your positives and negatives hooked up correctly here. But I had it hooked up in reverse, and so yeah, that's why originally the wattage wasn't shown. But then when I flipped it around, you saw the wattage was much more accurate, or actually showed up. And then the button there allows you to go from voltage to current to wattage. I think that's all that shows up here. But you can see these are about $45, and you can buy these all over the place. eBay, probably Amazon. Again, doesn't matter. So that's what that was for. And in my setup, I should actually hook up two of them. I should have one here, and then one here, just somewhere right in here, so I can actually see the wattage going directly into there, and the numbers should be fairly equivalent. Again, the reason why this is so much more instantaneous and this is like averaged. And this only gets kicked out about every 10 seconds or so, so it's kind of annoying, but it does give you an average of what you're putting in, and you can feel it. You can just feel, you can kind of guess what wattage you're doing just by how hard it is to pedal. I can easily tell the difference between 40 and 50 watts versus 100. It's not rocket science. And again, it really doesn't matter because you're just pedaling here to power this thing. And you can even take breaks. If after 10 minutes you're tired, just get off and hop off the thing. This thing will just stop charging it and then hop right back on and you start charging it again. It doesn't matter. What it's doing is it figures out how much current to put in this thing based on the amount of discharge. So what will happen is once you get to the third phase of charging or whatever, and you can look at the specs for how this thing charges. It uses that 4-stage charging. Eventually this thing gets up to enough of a charge where you can't get any more than 50 watts. In other words, if you pedal faster, it doesn't do anything. This doesn't get harder because with this small of a battery, it'll only put in 40 to 50 watts because it's on that slower charging cycle now that's better for the battery. And that's where a bigger battery might be more fun then. But after a little while of that, you just you take a break and you do whatever you want. But I'm saying this. What am I saying there? I'm basically saying you can take breaks, and you don't have to charge this all at one time. And I'm saying that even once this starts getting fully charged, you cannot produce more power than 40 or 50 watts because you can pedal faster, but it doesn't get any harder, is my point. Versus when this is totally discharged, you can make this be very, very hard and pump in a lot of power. And by the way, too, don't overpower this. If you have a battery here that you don't want to pump 7 or 8 amps into, then don't pump 7 or 8 amps into it. So if you're using this setup, you could easily overpower a smaller battery and fry the thing. So you got to just watch what the current ratings are, and they tell you too. I forget what the number is. If it's 10% of the amp hours. How does that work? See, I might even be overcharging these with the way I'm powering them, because this thing doesn't know what size battery it is, right? And so this thing could put a lot more power into this battery than it's designed to take. And I better actually look that up and see how much an AGM battery, typically how much current you should put into it. And I think it is a percentage of the actual amp hour rating on it. I had to look at that. So what did I just cover? I just covered the eFlight thing. So we've covered the plugs here. Oh no, I got to cover the plugs. Let me find those. So here's the other thing you want to get. Get back to where it was here. Okay. So you want to get these Anderson power poles. Now I got mine at powerwerx.com, powerwerx.com, and I bought one of these packages here. So I'll tell you which ones I got. And again, you can see these in the picture. So it's these things. Now there's 4 of them here. So there's one there, one there, one there, one there. And these are neat because they're almost like the male and the female are the same thing. It's kind of weird how they work, but all you need is the red ones and the black ones. They're all the same, and they just interchange. So you take 2 red ones and connect them together, and they both have a male and a female end in a sense. Gosh, I hope that makes sense. There's lots of videos on this. If you just Google power pole connector assemblies and YouTube, and you'll find a whole bunch of different ways of connecting these things. I love these connectors, and so there's videos on how to put them together. So here's what you get. I got the 45 amp versions unassembled. So here it is, 45 amp unassembled red black Anderson power pole sets. I got a 25 pack. Let's see how much they cost. Is the cost here? Oops. I don't think so. No, just the quantity. Okay. So anyway, so here's the ones I got. $15 for that set. Let's see. Permanently bonded. So these are unassembled, which means they're not connected. You can get them connected together here, but they also slide together. See that little slit right there? That will slide into the side of the other one. So you can put these together and they connect fairly well. But otherwise you can get them permanently bonded too. Now here's the connectors that go inside of them, and I'll show you here. You can get lower power versions of these too, but I went with a 45 amp. I just wanted something that was decent. So I got the 25 pack for 29 bucks. Now what you want to get is this crimping tool for this. Highly suggest just buying this thing, because if you're all into electronics, you'll realize how this works. And there you go. You can see these pieces working together. So this thing you see right here, that's these. So this is permanently in. This piece here is permanently inside there, and these things snap together. And here's two of them. So here's the one side and here's the other. And when they come together, these two pieces are pushed together and they make a really perfect bond there. And so these things, these metal things you see here, are the parts that actually touch together. So when you put your wire in there, and then you'll stick this whole thing in the crimping tool, and it'll just crush these two pieces around the wire. And man, good luck getting it out of there. And then these get shoved into the back end of this. And then you can see the little piece of metal in there. So this little piece will actually come over and curl around that, and that's how they're locked in there. Now you need a special tool to get it out of there if you want it out of there. And there is this RT1 tool. So right here. So that's what I bought. I haven't actually used it yet. So if you want to take these apart, you need that. If you don't, then just cut the wire and just forget about the piece. It's just gone. But I also use that too to actually push and help push the thing in there. But if you have thick enough wire, like on my thing, this is the thick enough wire over here. And I can just use the wire to push that assembly into the plastic piece, and it locks in there. I didn't even need the crimping tool. But if you're using some wimpier wire like this, you kind of need something to push that in there. Now some guy on the YouTube video, he was using just the part of a voltmeter, the probe from a voltmeter. Just use that to push in here. But if you're getting this stuff, you know, just get this thing, get the crimping tool, and then get the devices, however many you want. I wish I would have ordered more now, because I haven't maybe used half of these, but they're so handy to have around. I can't believe it. Now, which wire am I using, by the way? Remember, this stuff isn't that higher power, but this wire here, I wanted something thick. I got it almost a little too thick, but I was using, I wanted to have as little resistance as I wanted. So let me find the value on that. Okay, so it looks like I can't totally tell because the containers, the rolls that they're on, have that number stripped off. But I think they were 10 gauge, maybe. I think they were 10 gauge, 10 gauge wire. And I got multi-strand because it's easier to bend. But it was almost too thick a wire. It's hard to get it in the little screw connectors there. And so I probably should have gone a little thinner. Remember the gauge, the smaller the number, the thicker the wire. So if I would have gone 12 gauge or even 14, maybe 16, they come in every even amounts there. Might have been a little bit better. But it all depends on your circumstance. And as you can tell from this, they can take, what's the highest number they can take in terms of, okay, so the 45 amp version can take 10 gauge wire, and I was kind of maxing that out. Couldn't have gone much bigger. Probably should have gone a little smaller, but I was trying to keep it as good as I can, as little resistance as I could. Awesome stuff. That's how I connected everything together. I think I've covered everything. Covered the connectors, the wire, the MPPT controller, the gauge, this thing. The batteries, like I say, you can just get those any gauge you want or any power level you want. The connector, I said get the extra connector so you don't have to deal. See, these are Anderson connectors in there, but this is 3 different connectors you have there, and I put them together and they're all connected. But if I would have gotten this other connector over here, it would have been a little nicer, and I just could have soldered that directly to my 3-phase rectifier there. And that's kind of everything there. I believe I covered everything. If you have any questions, just leave a comment. I'll get back to you. I'll be checking this stuff and leaving updates. And then I've got other things too that I'll make available. So make sure to read the text underneath this, because I might even offer my engineering services to people that need help with this. Because that was one of the biggest problems I had. I just kept on trying to find the information, but if I just could have talked to an engineer, it would have been so much easier. And the few times I was able to contact engineers, because I could speak their language and I could actually be interested in their products and stuff. I got some very valuable information, but man, I got steered some wrong directions in a few times because I didn't know what I was doing. Even though I was an engineer myself, I didn't really have a good direction as to where I was going. So I might offer those engineering services, just call in either 15 or 30-minute intervals or an hour interval or whatever. So take a look underneath this video, and I'll if I offer something like that, I'll definitely be talking about it down there and telling you how to go about doing that. But I've given every piece of information here I could give for you to set this up. Just overall, this is about $500. This whole contraption here, I forgot how much, if that was 100, 150 for that whole bike thing. I showed you the prices. What was this? $10. This was 30. This was like 45. This is about $200. The meter up there was like 70. The batteries themselves, I think, were about $35 each, something like that. So when you put this all together, you're looking at a pretty penny. Maybe $1,500, $1,200. Let's see, 500, 600. Let's just say 700, 800 right there, 850, and then the bike. So if you have another bike laying around, oh, and this thing was, so yeah, maybe $1,000 if you already have a bike laying around. But totally fun and totally worth it. I'll do another video too where I'll actually show this hooked up to this, or to this, and then I'll have a DC to DC converter, and then an inverter. So the inverter then will give you 120 volts AC power, so that you can actually power things. And that'll be a shorter video because it's not as hard. But what's be interesting there is to actually take that to high schools and to show people how hard it is to actually make 100 watts. And that it's doable, but to do it for an hour would be very difficult unless you were an athlete. And it gives people a little bit more perspective on how much 100 watts actually is to create, because we take energy for granted because it's so cheap and it's so convenient. It's right out of the wall, and we just take it for granted. And it's just fun to show people what this is all about. So hopefully this video wasn't too long for you. I know it was getting up there, and hopefully YouTube will even accept a 50-minute video. Otherwise, I'll have to break it down into chunks. But again, if you have any questions, leave a comment, and if there's anything I left out, I will have extra little videos so you can take a look at the YouTube channel for that. I'm going to make a YouTube channel just for the electronic stuff here, because as many of you already know, I'm a chiropractor, and that's my primary hobby, or primary profession, I should say. This is my hobby because I got out of engineering years ago. And look at my chiropractic stuff too, because I tell you, the work there is astonishing of what you can actually do to the human body and improve the alignment and the functionality and the mechanics of the human frame is stunning. So look up some of my other YouTube channels and you can learn about that and get your body fixed. As I tell you, if there is ever a meltdown in this country where the electric grid goes down or the dollar goes down, you're going to want to have your body as in good a mechanical shape as it can get. And so there's a lot to learn about that too. Signing off. Thank you very much.